In the last lesson, we learned about the completing the square process. And if you took the completing the square process to solve a quadratic equation, you could solve any quadratic equation with that process. So if you took that completing the square idea and you applied it generically to the standard form equation of a quadratic equation, you would actually come up with a preset solution for x called the quadratic formula. And so you can see x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, this gives us our two solutions for any quadratic equation. And since completing the square was used to come up with the quadratic formula, a lot of times people won't use completing the square. They'll just skip straight to the quadratic formula. Now, it's very important that you understand that when you use the quadratic formula, that it is an equation, it is a formula, and it is set with x equals. You cannot just start with negative b. That's not what we're looking for. It's helping us find the solutions for x, and since it has the plus or minus, we actually have both solutions. Now, in order to make this work, your equation that you're using has to be in standard form so that you can identify the a, the b, and the c values. So let's take a look at example number 1. Example number 1, 2x squared plus x equals 5. Since we have an x term, an x squared term, and an x term, it would be easiest just to move the 5 over and set this problem equal to 0. And when we do that, we now can identify our a, b, and c parts and apply that in the quadratic formula. Now, you can leave your answer in one of two ways depending on which way is relevant. You can either leave it in simplest radical form, or you can convert it to a decimal, and that's in large part going to depend upon the directions or the type of problem that you're going to work. Now, what I'm going to suggest to you is that you become very, very comfortable including all of this into your calculator in one step. That way you're not having to do it in a bunch of broken part steps. So, and that'll speed up your problem as well. Alright, so that's just a simple example, and notice we said it has two real solutions, and we'll talk about how we can identify what type of solutions it has later. So at this point, you have a couple of sample problems that you could work, 3 specifically. Sample problem number 1, 2, and 3. So go ahead and put those quadratics in standard form and use the quadratic formula to come up with each of their values. Okay, so hopefully you've worked sample problems 1 through 3, and I'll just go ahead and walk you through the solutions here through each of these problems. Now, I want you to pay attention closely to the fact that we're talking about what types of solutions you should finish with, and so this is going to be a little bit topic of a later video, so just notice what we're dealing with on each one of those for right now. So in each of these problems, the first thing that you need to do is put them in standard form, and so we have to get this 35 over to the left side, so 3x squared plus 8x minus 35 equals to 0, and then I can say that a is equal to 3, b is equal to 8, and c is equal to negative 35, and this will help me set up my quadratic formula. And so I'm going to simply plug in, and this is again important, this is preset to be the two solutions, so it must say x equals. If you work a quadratic formula problem on the test, you cannot just start with the negative b, it must be x equals, so pay attention to that. So I'm going to say negative b, which is 8 in this case, plus or minus, because we need two solutions, square root of b squared minus 4 times a times c, all over 2 times a. Now, we've set everything inside the quadratic formula, and this becomes just a simple order of operations calculation, and so your calculator will do this for you quite effectively. So hopefully you've worked down the parts. I'm going to go ahead and move into the final answer. If we do this, we get negative 8 plus or minus the square root of 484, which actually ends up being a perfect square of 22, all divided by 6. Now, this is a unique situation where the radical was actually a perfect square, and we have real numbers here that can be combined together. So we have like terms with the negative 8 and the 22. And so in this situation, we actually need to break up the plus or minus and work on both of them individually. So I can say x equals -8 plus 22 divided by 6, or x can equal -8 minus 22 divided by 6. And then I can get my two solutions for each of these. And so of course we need to reduce any fractions, and then x can also equal to -5. So x is going to be 7/3 or -5. And so that's how we would use a quadratic formula. Alright, let's look at sample 2. Alright, again, we have kind of a crazy equation that's been given to us. So the first thing we really need to do is to get it set equal to 0. Now, what I'm going to choose to do this time is move everything from the left over to the right, since I already have my 2x squared over there. And when I do that, I get 0 equals to 2x squared. And make sure you write this in standard form. Minus 12x plus 18. Now, it doesn't matter if the equals to 0 is on the left or the right, as long as you got it in standard form equaling to 0. And of course, I can identify my a as being 2, my b as being -12, or my c as being 18. However, if I want to make life a little bit easier, what I can do with this particular problem is I can actually divide all parts by 2. And if you recognize that right off the bat, you will then narrow this down to x squared minus 6x plus 9 equals to 0. And hopefully this will give you a clear view that, you know what, this can actually be factored. This is x minus 3, x minus 3, x minus 3 equals to 0, or x minus 3 equals to 0, so x is equal to 3. And you notice we have one real solution. So notice, this was a perfect square trinomial. We only had one real solution. Now, if I did want to go forward with working quadratic formula, I could have done that simply by plugging in my values here. -12 plus or minus the square root of -12. Make sure you squared minus 4 times a times c all over 2 times a. And that's going to leave you with 12 plus or minus the square root of 0 over 4, which is going to be 12 over 4. And so then you're just going to get simply x equals to 3 in the same way that you did with the perfect square trinomial. So that's a unique situation that you'll see from time to time. Alright, and lastly we'll do sample problem number 3. We'll start by moving it to standard form. Now in this particular case we have a leading coefficient that's a -1, and you can keep it that way. So if you want to do a equals to 1, b equals, -1, b equals to 2, and c equals to -2, and we can plug that into the quadratic formula. If I work through that calculation, I should get this as being 4 minus 8 over -2. That's going to lead me to this, plus or minus the square root of -4, which we know is going to give us imaginary numbers. Now, if I break this up, or actually if I continue this, I'm going to get -2 plus or minus 2i all over -2. And then I can actually break this up, and the 2, or the -2, is a common denominator to both. So that's actually going to be 1 plus or minus 2i. And that's going to give us our final answer. At this point, you've worked a couple problems using the quadratic formula. And if you've been noticing in the sample problems, the directions have been kind of showing you what type of solutions we have and how many solutions that they're going to be. Well, we have a shorter way of figuring this out as opposed to solving the whole thing. The expression b squared minus 4ac, which sits under the radical portion of the quadratic formula, is called the discriminant. Now you got to understand, we're only taking the part underneath the radical. The radical is not involved with the discriminant. So if we take the b squared minus 4ac and we just calculate that singular part, it's going to give us one of 3 possibilities. And if you look at this little chart here, we can see that that value could be a positive number, could be bigger than 0. It could actually equal to 0, or it could be less than 0. And so that's going to tell us specifically what types of solutions that we're going to be dealing with. And you can see If it's greater than 0, or if it's a positive number, we're dealing with real solutions, and we have two of them. If it's less than 0, or if it's negative, then we're going to have the radical of a negative, which is an imaginary solution. Now the 0, if it's 0, that brings in a special case where we only have one real solution. And this is when we're dealing with a perfect squared trinomial. So if we go and look at an example, I'm giving you a nice example here in example 2, you can see we have 3 different problems. And all we've basically done in these 3 problems is change the c value. Now, if you look here, you can see if we take the discriminant of each of them, by changing that c value, that changes what the potential discriminant is equal to and then what the potential solutions are equal to. And you can see the difference there. Now, something that we've talked about before is the fact that the zeros represent the roots or the types of solutions that we have. And then again, here we can see that if we, in this green equation for x squared minus 6x plus 8, it crosses the x-axis twice, so it has 2 intercepts or 2 real solutions. X squared plus 6x, minus 6x plus 9 is a perfect square trinomial, so it only has one solution. And you can see x squared minus 6x plus 10 has no zeros, so this would imply that it has 2 imaginary solutions. So you can get a visual sense of what the discriminant is telling you as well. So let's take a look at sample problem 4. Here we have 3 problems for you to work. All we want you to do is to find the discriminant of the quadratic and give the number and types of solutions that are involved. Alright, so let's take a look at this. So if we remember, the discriminant is b squared minus 4ac. It does not involve the radical, so keep that in mind. So in this first one, that's going to be 6 squared minus 4 times a times c. If you work that out, you end up getting 0, which tells us that this must be a perfect square trinomial, and it could be factored. So that would be one real number solution. Okay, and so that's basically what the discriminant tells us. The other nice thing about the discriminant, if I wanted to solve this and I noticed that the discriminant equals to 0, then it would probably be a pretty good idea for me to factor it because it's a perfect square trinomial instead of going through the entire quadratic equation. Let's take a look at the next one. We have 6 squared minus 4 times a times c. This is going to give us 36 plus 144, which is 180. Notice it does not matter what the value is, as long as it's a positive value, as long as it's greater than 0, then we can say that this is 2 real solutions. And then lastly, we have 6 squared minus 4 times a times c. We have 36 minus 180, which leaves us negative 144. Again, doesn't matter the actual value, just that it's less than 0. And this is going to tell us that we have 2 imaginary solutions. Alright, and that's the final video on quadratic formula, using the discriminant to tell the number and type of solutions.